PreAP, PreCalculus, Notes 3.3. We just did the remainder theorem. Now we're going to check out the factor theorem. The factor theorem is directly derived from the remainder theorem. The remainder theorem said that if you divide f of x by x minus a, then the remainder is the same as whatever f of a is. Now the factor theorem is saying that anytime x minus a is a factor, then f of a is going to be 0. In other words, if the remainder is 0, then whatever you divide it by is a factor of the polynomial, which makes sense because if something is a factor, it means it goes into it evenly and there's no remainder. Let me give a too long didn't read version of this. X minus a is a factor. Therefore, x equals a is a 0. So what does this do for us? It's going to save us 1 to 3 seconds on a lot of problems. X minus a is a factor, therefore x equals a is a 0. So let's check this out. Before we look at these test and quiz-like questions, let's see if we can kind of give an idea if this actually works. Does the factor theorem actually work? The equations of the functions below are given in both factored form and expanded form, and a graph of the function is given. From the graph, identify the zeros of the function. So identify the zeros of the function. Then synthetically divide the expanded form of the function by each factor. All right. So the zeros of the function are -2, -1, and 1. We're supposed to take the expanded form and divide it by each of these little fellas. Now before we do that, let's just check out the factored version of this. X plus 2 is a factor. X equals -2. -2 essentially is a 0. X minus 1's a factor. 1's a 0. X plus 1's a factor. -1 is a 0. That already is showing that the factor theorem is working. Let's follow the instructions. Let's take the coefficients of function f, which are 1, 2, -1, and -2, and let's divide it synthetically by each of these zeros. Works out for -2. Let's check it for -1. Remember, we add down and then we multiply. We add down and we multiply. We add down and we multiply. So that worked. How about 1? Zero and 1 is 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. -1 plus 3 is 2. 1 times 2 is 2. Remainder 0. So it looks like this actually works, the remainder theorem. I'm sorry, the factor theorem. We've already established the remainder theorem works. This next one, this 0 here, looks like it's -2.5. And if you look at the factored version of this, that would confirm that it would be -2.5. This looks like it's 1. This looks like it's saying it's 1 here as well. So we're saying x is -2.5 x meaning the zeros, and also 1. Let's divide this synthetically. And we got some coefficients that are, not the greatest things in the world, but that's okay. We can suffer through it. I'm not missing any terms. If you're missing any terms in the polynomial, you want to put zeros in their place. 0 plus 0.4 is 0.4. 2.5 times 0.4, that is negative 1. If we add these, we get negative 1.2. Negative 2.5 times negative 1.2 is 3. If we add this, we get 1.2. 1.2 times negative 2.5 is negative 3. We add this, we get negative 0.4. If we multiply this, we get 1, remainder 0. Confirmed. If we divide by 1 synthetically, so it checks out. This is confirming the numbers that we chose were correct. This also confirms that if x minus 3 is a factor, then, x minus 1 is a factor, then 1's a 0. 2x plus 5 is a factor, then negative 2.5 is a 0. Let's look at problems that would actually appear on tests and quizzes. Answer the following questions about factors and synthetic division. Is 2x plus 1 a factor of this, of g of x? Show and explain your work. What is the graphical interpretation of this work? I can show this in a couple different ways. I can divide this synthetically by whatever would make this a 0, which would be negative 1/2. Or I can take a negative 1/2 and plug it into this and see what I get. Hopefully you can see that if I put a negative 1/2 into this, it's going to be problematic. End up with negative 8 and a positive 4th and a negative 1/2. I have to get common denominators and add them together. It's kind of a mess. So let's take my factor and set it equal to 0 and solve it. X is negative 1/2. So we are suggesting that negative 1/2 is a 0 of this. So I'm going to divide it synthetically. Coefficients are 2, 3, negative 11, and negative 6. With 2 down, 2 times negative 1/2 is negative 1. Add, negative 1/2 times 2 is negative 1. Add, negative 1/2 times negative 12 is positive 6. Remainder 0. So let me make sure we're answering the questions. Is this a factor? Well, we need to answer yes that it is, first of all, which I'll do here shortly. Show and explain your work. We just showed our work, but we have not explained it yet. I'm going to explain my work and say if it is or isn't a factor here at the same time. G of x divided by 2x plus 1 has a remainder of 0. Therefore, by the factor theorem, 2x plus 1 is a factor of g of x. And what does that mean if it's a factor? The conclusion we can draw from that is that x equals negative 1/2 is a 0. Now we want to say that because the last part of the question says, what is the graphical interpretation of the result of this work? And that is the graph of g of x touches the x-axis at x equals negative 1/2. There's a lot of information that we wrote down there. It's a typical response. This right here, typical way that you would write your answer on a free response question on a test or a quiz. All right, let's check out number 2. Consider the function f of x, divide it by x minus 3, and then factor the quotient. Based on your work, what are the zeros of this function? So let's do this. Let's first divide this. So to divide it, I'm going to take whatever I'm dividing it by, the factor, well, potential factor, setting it equal to 0 and solving it. So I'm going to divide this by 3 synthetically. 3, the coefficients of x squared minus 13x plus 12 are 1, 0, negative 13, and 12. I think that I just lost my headphones. No, I just got a weird sound. So if I divide this synthetically, I'm going to get 1, 3, 0, 3, negative 10, negative 30. I think I made a mistake. Oh, I did. 0 plus 3 is 3. Let me start this over. Bring down the 1. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 13 plus 9 is negative 4. 3 times negative 4 is negative 12. I add, I get 0. So here's what this tells me. 3 is a 0 of this function. X minus 3 is a factor of this function. Okay, then it says factor the quotient. This is the quotient. Well, it's the coefficients of the quotient. So this problem, f of x, I'll write this over here, has a factor of x minus 3, and the depressed polynomial, the quotient, is going to be x squared plus 3x minus 4. That's because the coefficient of 1, 3, and negative 4 are seen here, and the remainder 0. I'm supposed to factor the quotient. This is the quotient. So my factor is x minus 3. Two things that multiply to get negative 4 and add to get 3. That would be x plus 4 and x minus 1. Assuming that I can add and subtract or add and multiply correctly. I don't always. Based on your work, what are the zeros? Well, according to the factor theorem, since these are factors, the zeros of f of x are x equals, what are we subtracting from x here? 3. What are we subtracting from x here? This is really x minus a negative 4. Another way to look at it, what would make this equal to 0? Well, a negative 4 would. What would make this equal to 0? A 1 would. All right, we got 3 more. Is x minus 1 a factor of g of x? What are the other 2 factors of g of x? And rewrite g of x in completely factored form. The problem with this, not a problem. Never mind. So let's answer the first part. It says that x minus 1 is a factor. So if x minus 1 is a factor, let's see what happens if we factor that out. And in fact, can we factor it out? So let's take this. To make this a 0, the function, we'd have put a 1 in there. So 1's a 0, x minus 1's a factor. Take the coefficients, synthetically divide. This should go evenly, should get a remainder of 0 because it says it's a factor. Add, multiply, add, multiply, add, multiply. So that tells me that g of x factors into x minus 1 and 2x squared minus x minus 3. So we got to factor this fella right here. I'm going to do that off to the side. I'm going to split the middle term and factor by grouping. I need two terms that multiply to get 2x squared times negative 3. That's a negative 6x squared. Same two terms add to get the middle term of negative x. So that would be, let's see, negative 3x and 2x. Does that work? Negative 3x times 2x is negative 6x squared. You add these. Yep, so that works. So this middle term is going to be negative 3x plus 2x. And if I group things together and take out the GCF, I'm going to get x and 2x minus 3 plus 1 and 2x minus 3. It's going to give me a factor of 2x minus 3 and x plus 1. Did this off to the side intentionally so I didn't muck up my work over here. Pardon me for the language. So this is x minus 1, x plus 1, and 2x minus 3. What are the other two factors? We haven't answered that question yet. Rewrite g of x in completely factored form. We've just done that. So let's answer the other question. The other two factors are 2x minus 3 and x plus 1. Answered the questions. Now it turns out that we could have factored this directly from the beginning, I believe. We could have factored by grouping at the beginning and avoided all of this. It's fine, we didn't. 4 and 5. For what values of k is x minus 2 a factor of this polynomial? So we've done similar things for the remainder theorem. So if this is a factor, then that means that means 2 is a root. So I'm going to be dividing this by 2. And we have the coefficients of 6, negative 19, k, and 6. Add, multiply, add, multiply, multiply. And then when I add this, I'm going to get 2k minus 22. So let's reread the question. For what value of k is this a factor? If this is a factor, what this is implying is that the remainder is 0. So 2k minus 22 has to be a remainder of 0. So that means that 2k minus 22 should equal 0. So we're going to get that k has to be 11. Answering the question, sentence form, x minus 2 is a factor of p of x when k equals 11. Last one. Is x plus 1 a factor of this? If so, how many times is it a factor? Well, that's interesting. Well, let's see. If x plus 1 is a factor, then that means negative 1 is a 0. So let's see if we divide this by negative 1, if it's going to go evenly. So our coefficients are negative 3, negative 7, negative 3, 3, and 2. So we add and we multiply, and we add and we multiply, and we add and we multiply, and we add and we multiply. We get a remainder of 0. So it's a factor once for sure. So that checked out. Let's do it again. Now, when we do it again, we can just take the depressed polynomial and divide it by negative 1. I'll use a different color for this. See if this works again. So we add and we multiply, and we add and we multiply, and we add and we multiply. We got remainder a second time. So this has worked twice. Let's see if it works thrice. Did I make a mistake? Yeah, I did make a mistake. It worked thrice times. Perhaps it works 4 times. Negative 3 times 0 is negative 3. Negative 1 times negative 3 is 3. You add these, you get a remainder of 5. It did not work this last time. So depending on how you're counting, it worked 1, 2, 3 times, or if you prefer to say it worked 1, 2, 3 times, didn't work this time. So the first question is x plus 1 a factor? Let's answer that. X plus 1 is a factor of p of x. And then the second question is, if so, how many times is it a factor? So we can just add to this sentence. X plus 1 is a factor of p of x 3 times. Alrighty. It is p of x? No, it's f of x. I'm sorry. This is function f, not function p. Was the last one p? Yes, it was. X plus 1 is a factor of f of x 3 times. So your instructions are to do the homework for this section, 3.3. Thank you very much for paying attention.